When it comes to adding or subtracting radicals, it's the same premise as combining like terms. You're used to combining 3x's and 4x's to make 7x's. The same is actually true when you are adding radicals. For example, if we take 3 radical 2 plus 4 radical 2, we will get a total of 7 radical 2's. When we are adding radicals, we have to have the same radical that we are adding 3 of and 4 of. If this is a cube root of 2, this would also have to be a cube root of 2 to be able to combine them. These are square roots of 2. So the radicand and the index have to be the same. All right, so this is the square root of the same number. 3 square roots of 2 and 4 square roots of 2 make 7 square roots of 2. Over here we have the same coefficient, 1 square root of 2 and 1 square root of 3, but these are not the same radicand. This is a radicand of 2, this is a radicand of 3, so this is already simplified. You cannot do. It's not possible to add those or to simplify. You can add those quantities, you're going to have an irrational answer. So this is actually the simplest way to write this sum. All right? We're not able to do that. Over on the right side, we have 6 cube roots of 2 plus 4 square roots of 2. This is also not possible to add, all right, or to simplify. We can find out a decimal approximation of this, a decimal approximation of that, and we can find a decimal approximation of that sum, but it's not possible to combine these because this is a cube root and this is a square root. Yes, they're of the same number, but this is a cube root of 2 and that's a square root of 2. These have different values, so we're not going to be able to simplify that. Finally, over here, we have 2 cube roots of 3 minus 5 cube roots of 3. When we subtract, we've got the same type of radical, the same radicand and the same index. So we have the cube root of 3. We've got 2 cube roots of 3 minus 5 cube roots of 3. That makes negative 3 cube roots of 3. When adding and subtracting radicals, you simply combine like terms.